Hello everybody. So our lecture today will be talking about the Central Coast bioregion, and that'll kind of finish this section where we're talking about and focusing on a few different bioregions, at least the local ones to where we're at over in Bakersfield. So in terms of the Central Coast bioregion, let's kind of wrap it up as quick as we can. So we're talking about northern Napa County all the way down to northern Santa Barbara County, and then even all the way up, basically all the San Francisco Bay Area down to the Los Padres National Forest. That's what we're talking about in terms of the Central Coast region. For me, one of my just favorite parts of California, if not my favorite part of California. I mean, I did undergrad at UC Santa Cruz, spent a lot of time in Santa Barbara, just love the Central Coast. This area is heavily urbanized, so parts of it, and we'll talk about it when we get to the ecological zones. One of the ecological zones is just basically, this is the area that's full of people because that's just the way it is. It's very full of people. But what's interesting about the Central Coast, because if you're from California, you get it. But if you're not from California, it seems kind of odd. But, you think of this area and you're like, oh, San Francisco and Napa and Santa Barbara, Monterey. And you're like, oh, these places are just full of people. We have specifically heavily urbanized areas along the coast. But then the inland part, or the part once you get away from the coast, because of such rugged topography, you get actually quite rural in a lot of these areas, and nowhere near heavily populated. So it's kind of interesting, because I think if you talk about the Central Coast of California to most people, and you say, San Francisco, San Jose, Monterey, Santa Barbara, San Luis Obispo, people would be like, oh, wow, that's just full of people. It is, but only in a few areas. It's actually a lot of still rural area within that Central Coast region. And one of the reasons is this next big part, the idea of that rugged geography mixed with the valleys. The valleys and the flat areas near the coast basically got settled right away, including heavily populated by Native American communities. But in terms of the more rugged areas, those stayed more rural. You've got a bunch of mountain ranges, so the Santa Cruz, Santa Lucia, San Rafael, Diablo, Gabilan, and Temblor mountain ranges. And then you also have that mixed with the Santa Clara, Salinas, and Santa Maria River valleys. Your elevation for this area, we're going from sea level all the way up to about just under 6,000 feet. And then you've got geology, which is marine and non-marine sediments. And when we're talking about the marine sediments, we're talking about mostly like sandstone and shale as our rock formations underneath us. What's interesting, at least I think, what probably draws me to the Central Coast, other than, of course, the ocean, is the complex local vegetation mosaic. So the idea of the rugged topography, the idea of the influence of the climatic patterns of California, the mixing of grasslands and chaparral and forests, depending on whether you're in the northern part of the region or the southern part of the region or the interior part of the region. I think it's probably to me the prettiest part of California, because you get so much variety and you get so much difference. I know there's a lot of other people who would argue for the Sierra Nevadas, but growing up as a kid who comes from this area, being raised in the East Bay, there's just so much of this area that to me just feels like home, that I'm just so used to it, and I just understand it, and it just seems perfect to me. But the vegetation mosaics, it's basically everything that we've talked about. We've had these heavily urbanized areas, so there's been a large anthropogenic influence for a long time. So things things may have looked one way a long time ago, but there's been a heavy influence to change those. You've got rugged geography, so you've got valleys, you've got foothills, you've got mountains, so you get all sorts of different vegetation growing depending on aspect, depending on temperature, depending on if you're on the coast and you get that constant marine layer or not, and get that fog influence depending on whether you're in the northern part or the southern part, and the amount of precipitation you get. It's really interesting to group this together in one grouping with how different some of the areas can seem. But when you're trying to put it into these large regions, it does make sense that this area goes together. So in terms of our climatic variables, so really when people talk about California having a Mediterranean climate, this is the area that they're really talking about. So this is the area that gets those cool, wet winters and the warm, dry summers. You got over 80% of the seasonal rain is falling between November and March, and precipitation definitely decreases from the north to the south in the region. So you can get in the Santa Cruz Mountains, you can get redwood and Douglas fir forests, but you're not going to get those down in the Los Padres. So you get plenty of precipitation up in the north, but once you get to the south, especially the far south, you're getting into much more arid, xeric type of conditions. And then because we've talked about that, how all the weather comes from the ocean in California, and we get it, it's got to kind of work its way inland, and it's got to push itself over the coast range. You do get a small rain shadow along the eastern edge, and that's what we see in the Central Valley, why we don't get a ton of rain here in the Central Valley, because the coast range, it gets sucked up on that western side, and we get that, the warm, dry winds coming down the east side. Not as dramatic as the rain shadow that comes off of the Sierras, because it's just not as high. You don't get as much pressure building up, and then that steep drop off that you get on the eastern edge of the Sierras. Here it'll get build up, and we'll get a partial smaller rain shadow, but just not anywhere near what they see on the eastern side of the Sierras. As I've mentioned before, as anybody who comes from the California coast, or I spent time on the California coast, they're used to that marine layer that persists through the rainless season. The Mark Twain quote, the coldest winter I ever spent was a summer in San Francisco. The idea that when you go to the beach, you go to the beach in jeans and a sweatshirt. That's this area that we're talking about, because it stays cold throughout most of the year. It never really gets super hot for long periods of time, the way other parts of California does. Central Valley, what's it going to be in the Central Valley? Oh, it's 108 today. Well, let's go to the coast because it's only 80 degrees at the coast. 75 degrees at the coast. So that marine layer, though, is extremely important in that species diversity, which I find to be really interesting about this area, though. Because that marine layer is extremely important for plants. So for 4 reasons. It absorbs and reflects solar radiation, so it keeps the temperature down. It lowers temperatures, so it lowers the temperature. It absorbs and reflects solar radiation, so we're also getting good amount of absorption of solar radiation. It increases the humidity, and plants like it when it's more humid, easier to grow when it's more humid, because they're not spending as much energy trying to keep themselves cool. And then it directly inputs that moisture through in the areas that get fog drip, or just through actual precipitation in some areas. And so that's how you end up with gigantic redwood trees growing in the Santa Cruz Mountains. Because you have that moisture, that constant moisture, right? Trees spend basically all their time trying to keep cool. But if you live in an area where the weather itself keeps you cool all the time and you don't have to spend time trying to keep cool, then you can spend time trying to be one of the biggest organisms on the face of the earth. And that's how you get redwood trees growing in the Santa Cruz Mountains. Obviously, we don't get as much of a marine layer down south as we do up north, and that's part of it, and that's why you see that difference in vegetation from north to south. So I don't think that you can address this area without talking about the anthropogenic influence of humans in this area. And the book definitely does a good job of going through it, where even native populations have been in these areas at high densities for thousands upon thousands of years. They talk about it as the early Holocene. So we're saying over 10,000 years ago, people were still in this area and populating these areas. Most of the increase in population has been near the coast, and most of the interior actually remains rural, which I think is very interesting and creates a really interesting dynamic with the Central Coast region, because a lot of people, you'll hear them talk about California and they want to talk about areas like Santa Barbara, but have no idea that you can drive down 101 and just be looking at wide open spaces for large swaths and large periods of time. In terms of the south of the Central Coast bioregion, 78% of the region is privately owned. So almost 80% of the whole region is privately owned. You got the Los Padres National Forest at somewhere around 2.5 million acres as your largest public land holding within the Central Coast bioregion. So in terms of historical fire occurrence, so what happened before the current period. So Native Americans, we've talked about this before, but the idea that Native Americans used fire extensively to manage vegetation, there's a lot of proof of it in the Central Coast, just because of the large amount of the large densities of Native Americans, and then just the idea of what these lands look like today and the way that they look. It kind of gives us that proof that it had to have happened, because one of the things we do know about this area is that our other source of ignition, which is lightning, this is the area of California that gets the least amount of lightning strikes of all of the bioregions within California. So we are severely lacking that other form of ignition source. So more than likely, the majority of ignition sources have been anthropogenic in this area, and the people living in this area for the longest time were the Native Americans. They used burning to convert areas of coastal sage scrub and chaparral to grasslands, because grasslands are much more inhabitable and easier to move through. Other areas, like up north where the Ohlone were living, they were burning to increase the growth of bulbs and seeds for the plants that they eat. And this area, or this era of Native Americans, really is an era of anthropogenic change, where we start seeing human influence on this part of the Central Coast bioregion, and it really doesn't stop. It just kind of progresses to a next level and a next level and a next level up in terms of how much influence we're actually we're having on this region. What's interesting in terms of the historical fire occurrence, and we don't really get this in a lot of the other regions, definitely not the ones that we've talked about, is that large fires, so fires over 300 acres, have a long history in this region. It is common to see large fires in this region, and there's a lot of reasons for that. It's the land use conversion. It's there was a long history of logging in this area. Fire was used anthropogenically to increase travel corridors so people could get from one place to another. Really just the idea that people have always been here. People needed to get things done. Fire was one of those tools to get things done, and that you have vegetation that readily burns in large groups, basically. So you've got an area filled with chaparral and coastal sage scrub and large grasslands and areas that are just burn really well. And when they do burn, they burn large swaths. It's hard to keep them from burning large swaths, because especially in areas of chaparral where you get everything growing to the same height and just it's just one big long canopy of things to burn. So how do we know that large fires have had a long history in this region? Well, let's just take a look. Now this is just recently in the down in the Santa Barbara area, but you can look in just recently. So we're only looking at the the 90s and the 2000s, and we're looking at just fire after fire after fire. Now, if you're like, well, yeah, but this is what's happening recently, and you told us about all the changes recently. Yeah, but this is just an example of just what kind of happens in this region over and over again. It is just this region likes to burn and likes to burn in large fires. This red line here being the Thomas fire, one of the big fires recently down in this area. It's the vegetation is just set up to burn together because of the way that chaparral and coastal sage scrub grows kind of as one big canopy. You've got a lot of closed cone pines that depend on fire in order to reseed, so they're very accepting of fire. You got just lots of people, and we know the number one source of ignitions in California and in the United States is human beings. So you've got the perfect combination of the Mediterranean climate where everything dries up in the summer. You got tons of people, so you got lots of different ignition sources, and then you got this big perfect canopy of stuff that just when you're gonna burn one of it, you're gonna burn all of it. And that just sets us up for this long history of big fires consistently throughout this whole region. So in the current fire period, what's been happening? Well, a lot of fire suppression, but fire suppression mostly focused on the heavily urbanized areas. But that fire suppression, just like fire suppression in the majority parts of California, has been pretty dominant. So you got your fire frequency for this whole area would be more like 10 to 30 years. Now it's more like 25 to 35 years, and that's a big change in terms of fire frequency. If you think, that in some areas fires coming every 10 years, and now it's coming every 25 years. So you went from 10 fires in 100 years to 4 fires in 100 years. And so, that's a big shift. In the Santa Lucia ranges, so farther down south, more toward, Los Padres National Forest. If you don't know the Santa Lucia ranges, we'll talk about it in a little bit. A quarter of that region has burned since 1950. This area, just like we were showing with Santa Barbara, because that's the southern part of this area, you get much larger fires than you do in the north, and it's really the reasoning for that. Actually, the dominant reason for that is extreme weather events. So it's that Mediterranean climate going to the extreme. So we get the cool, wet winters, and then we get the warm, dry summers. Well, when we get our droughts in California, now you get a cool winter, no wet part, just a cool winter, and then you get a warm, dry summer. And then you get another cool winter, no wet part, and a warm, dry summer. And all of a sudden, now we got fuels that are ready to burn. We got a bunch of people who don't pay enough attention when they're outside, and now we got everything set up for big, huge fire because our vegetation doesn't mind big, huge fires. That vegetation is very much okay with a stand replacing fire. And so everything is set up for large fires in the southern part of this region. In the interior coast ranges, so the inside, the inner part of this region, so at Pinnacles National Monument, at least 40% of that area has burned since 1950. You got that high frequency of human ignition, and then 15% of the interior coast ranges has burned in large fires. So not only has a lot of the area burned up, but it's also, you got at least 15% of it burning in these big, large, 300 acre plus fires. And so just like our other regions, we're going to focus on the ecological zones. And the reason that I used this map here, and just wanted to point out a few things to you, is our Central Coast region is this area right down here. And the one thing that I really wanted to point out to you is when you look at the other areas, so the Central Valley, the Sierra Nevadas, the foothills, the Humboldt area, the northern forest area, the desert area, all of that pretty much dominated by one color. Not all the same colors in all the areas, but most of it dominated by one color. But then when you look down here in the Central Coast, we got dominant blue here, then we got dominant yellow here, then this dominant purple streak here, then some more blue, a lot of light green, we got some black down here, we got some red area. We get a lot more mixture of colors in this area. And if you look at our color scheme here, you can see we've got a lot of different types of vegetation. And that's, to me, what I think is just really interesting about this area, the Central Coast region. You've got so many different types of vegetation growing that it makes it a fascinating place. So the ecological zones, they've got 4 ecological zones, but then they did even some sub zones to focus on some species. So let's get into it. So the first one that we're talking about is just the developed plains, valleys, and terraces. So these are all the flat areas which are dominated by urban and agricultural use. And so like Silicon Valley here, there's really not much worry about, or really not much use either for wildland fire, because it's so developed and so urbanized that we're not really talking about the environment so much, and the areas outside of the cities. It's so fragmented, such a fragmented landscape that there's really not much we could do in terms of trying to talk about fire ecology or what happens, because this is an area just dominated by fire suppression because so many people live there, and we have nowhere near continuous fuels to have a huge concern in terms of wildfire. Now that doesn't mean that it's the whole area. We're just talking about these developed plains, valleys, and terraces where they're just so heavily urbanized or used by agriculture. So in the Santa Cruz Mountains, maybe you can see me down there, kind of. I'll be walking on this trail. So in the Santa Cruz Mountains, we get high rainfall, high topographic relief, and areas where you can have extensive forests, like this picture of Doug fir and redwood, and a very low occurrence of firewood, which is a very low occurrence of fire, which is obviously a big difference from the southern part of this bioregion. Your major ecological zones, you get the coastal prairie and sage scrub, you get the coast redwood Douglas fir forest, you'll have areas of chaparral, and then you'll get oak forest woodlands. But then the book also focuses on some closed cone pines within this area. And so within the Santa Cruz Mountain areas, you get 2 closed cone pines. You get Bishop pine and you get Monterey pine. So both of these pines, they're both non-sprouting and moderately serotinous. And what it means by moderately serotinous is that the cones do not need fire to free the seeds. They will just open up and drop seeds they don't need fire the way that something like lodgepole pine in the interior west has to have fire. In Bishop Pine, cones can open on hot days, and they can establish in the understory of a mature stand. And Bishop Pine increases as you go farther north within this region, and interestingly enough, because you get an increase in serotiny as well. So as you go farther south, because you get that regular heat, I don't think it relies on fire as much because you get a much more regular heat. So they're less serotinous as you go farther south, and as you go farther north in this region, they're more serotinous because they're more reliant on fire because you don't get those hot days that the cone can just open on its own. With Monterey Pine, the seed release is highest following fire, so it definitely got adapted to fire at some point in time. But it does release seeds every year, and it can establish in the understory similar to Bishop Pine. Monterey Pine is a short-lived tree it lives less than 8 years, and it's got really thick basal bark. You see it's very picturesque. You see it a lot on the coast. It has two current issues right now in terms of Monterey Pine. There's what it calls a senescent risk, which is adult trees that just aren't dropping, don't have any reason to drop cones, so they haven't dropped their cones, and possible that the seeds are losing viability because they're not dropping cones and not dropping seeds and not creating new cones. So they're at this senescent risk of losing the viability of their seeds because the trees are basically aging out. And then also pitch canker, which is a fusiform rust issue, is affecting the trees as well. So on the left here we have Bishop Pine, and on the right we have Monterey Pine, a very similar look. So I'll move myself down here, hang out over by the ocean. But you can see kind of similar looks, grow in similar areas, very similar type trees growing in the Santa Cruz Mountains area. In terms of the Santa Lucia ranges, so we're talking about basically Big Sur area and down. We're talking about extreme ruggedness, moderate rainfall, extensive shrublands, montane hardwood, mixed hardwood, and mixed hardwood forest, and you get a high occurrence of wildfire. So I mean, you got the Santa Lucia ranges. You're going all the way from Big Sur all the way down to Los Padres, basically. So all that area in between, up here and down, this area is just prone to wildfire. So the chaparral areas and the mixed evergreen forests those are the ones where you get the most widespread fire-prone vegetation type. So those are the ones where you're getting the areas where your vegetation has just adapted perfectly to fire. You get chaparral that wants to grow in one thick stand, wants to burn in a crown fire, and wants everything to burn to the ground every single time because it can handle that. And you've got the forest that grows along with it that's adapted to that as well. So let's talk about some examples of that. So first, we'll talk about the coast live oak forest and woodland. So different from what we've mentioned with everything else, but still, to me, adapted to the same fire regime because it's adapted fire resistance as opposed to fire dependence as some of the other places. So coast live oak is one of the most fire resistant oaks in California. Both its seedlings, so the tiny trees, and the saplings, the one where it's starting to become a tree, they can survive low intensity surface fires. In some studies, mature adult trees have a survival rate of 95% after even severe fires, and the canopy volume can return back to normal after 5 to 10 years, which is pretty impressive. You've got they are shade tolerant. They've got dense outer bark. They've got thick inner bark, and they can resprout from the base and the crown, as well as some epicormic sprouting as well. They've got a deep litter layer, which now, based on what we've learned with other trees and having a deep litter layer, it's like, oh, that can help spread fire and all that. This deep litter layer, most of the year, has the fuel moisture in the litter layer actually is too wet to be conducive to fire spread, and so it's only in the extreme weather conditions that it is actually conducive to fire spread. And then there's a lot of thought that the only difference between coast live oak areas and the maritime chaparral areas or the coastal sage scrub areas is the time for the oaks to establish. So longer fire return intervals, you get coast live oak forests and woodlands. Shorter ones, you get maritime chaparral and coastal sage scrub. And the theory would then be that the climax species for this area would be the coast live oak forest. In terms of maritime chaparral, chaparral itself in California goes all the way from Mendocino County to Baja. But in terms of the chaparral specifically here in the Central Coast, it's amazing because it's got the highest species diversity of any of that stretch of chaparral all the way from Mendocino County to Baja. You will not find more species of chaparral anywhere in California the way you will in the Central Coast bioregion. It's got, even within the bioregion, the maritime chaparral, the chaparral on the coast, has twice as many species as the inland chaparral. You also have a higher ratio of obligate to facultative cedars, so the majority of species that you get here in the maritime chaparral are going to be obligate. They only have that one way to be able to regenerate, as opposed to facultative, who have multiple methods of regeneration. The maritime chaparral is usually dominated by chamise in terms of species. You'll also get your manzanitas and your ceanothus as well, but mostly dominated by chamise. You get a lot of rare and endemic shrubs, including parts of the including some of those major chaparral species. Some of them are endemic. They specifically need to grow in this area, and they're only found in this area. Especially the ones that are rare are definitely fire dependent, and usually they're either sprouting or they're getting recruitment from a buried seed bed. It's usually one of those methods. And then maritime chaparral, like we've mentioned, we got that large anthropogenic fire history, which is really kind of shaped where we see the maritime chaparral. We see it up on the hillsides with the rugged topography, the areas where you don't get people settling because they basically burned those areas, turned them into grasslands, and then they could settle those areas and kept the chaparral shrublands to the areas where you weren't getting people to settle. So on the left here, we've got our coast live oak, and you can see kind of much more of a woodland aspect. Coast live oak with an annual herbaceous layer below. And then on the right here is a look at maritime chaparral, and specifically a hillside dominated by chamise. So all this beige color, this photograph was actually taken when the chamise is in bloom. So all this beige colored stuff here, that's all chamise dominating that chaparral hillside. And then you can see, you get to the higher elevations and you can get some of those pines mixing in there as well, and into the deeper, wetter areas. So a few other species that get focused on in the Santa Lucia ranges. So coulter pine, which I think is a really interesting tree, mostly because of the cone, which is amazing, and I'll show you a picture of. It's the most widely distributed closed cone pine in the bioregion. It's an overstory tree in the dense montane chaparral. And coulter pine self-prunes poorly, so whenever the crown fires happen in the chaparral, the coulter pine is going with it. So you might say, oh, well, that tree, like, why wouldn't that tree develop self-pruning? Well, because that tree wants to burn. It is okay with burning up in these stand replacing crown fires. It has adapted itself to that regime because it wants to grow with the chaparral. So it's highly serotinous. So it's got a heavy winged seed, which it relies on rodents and birds to bury those seeds in the caches. So you get a crown fire. The crown fire melts the resin, opens up the cone scales. The seeds, the heavy winged seeds, drop, usually with pretty close to the area because they're heavy. So even though they're winged and they can move around, unless you get a good breeze, they're just going to fall within the area of the tree. And then you get rodents and birds to bury them in the caches, and then you get the trees to come back up. Your saplings are producing cones by age 10. And then if you do get coulter pine in these areas where it's less chaparral and more like the oak woodlands, you'll see less serotiny because they're not as dependent on those crown fires. They know it's going to be much more of a low intensity surface fire regime, so they know that they can't produce serotinous cones, and they adapt to that. With knobcone pine, it's a medium-sized, short-lived conifer that grows in dense stands. Also self-prunes poorly. Also finds itself living in chaparral, and it is fire dependent for the release of the stored seeds, similar to the coulter pine. What's interesting by knobcone pine is that knobcone pine really has adapted itself to fire. It produces cones by age 2, which for a tree is exceptional. Most pine trees, when I've seen them when they're 2 years old, you're talking about, a couple feet of a tree, and the thing's already can be producing cones by that age. Where you get surface fires and knobcone pine as opposed to the stand replacing crown fires, you're gonna see some uneven stands because you get adults that survive, and then also saplings that can come up in the understory of the mature stand. And then another conifer that we get in this area is Sargent cypress. So it's a fire-dependent obligate seeding species that releases massive amounts of small wingless seeds after crown fires. So Sargent cypress, very adapted to fire, very much wants crown fire and wants to just throw seed all over the place. So what do these species look like? Well, let's first look at coulter pine. So this is a photo of the Dick Smith Wilderness, and then this is it after a fire in 1933. So remember, I talked earlier about this area, the Santa Lucia, the southern part of the Central Coast bioregion. It's just ready to burn, just wants to burn. So this is a big, huge stand replacing fire in 1933, and then this area burned again in 2007 in a big, huge fire. The Zaca fire, I think, is still in the top 10, but we've had so many huge fires recently. The Zaca fire might be now only just in the top 20 in terms of largest fires in California. Right here is a coulter pine cone. The closest thing I could tell you to give you, if that doesn't give you enough of a comparison, is to basically think of the size of a football, and then to think of a big pine cone that is a big open scaled pine cone the size of a football, and that's about what a coulter pine cone looks like. And you can tell these are coulter pine trees because if you look right here on the tree, you can see that big old huge pine cone, really similar to this. So it's a super cool pine cone. I think it's an interesting tree. On the left here is knobcone pine, and knobcone pine always has these got this little like funky twist to its pine cone. So you can see some of these have opened up and some are still closed, and this one's more fully open, but it's got this kind of a little crook in its pine cones. On the right here, this is Sargent cypress, so you can kind of see similar habitats for both of these species. And then we get the interior coast range, so the other side, and you can just see by the look in this picture and the vegetation, that idea of the rain shadow that we talked about, right? Not as much less vegetation. If we go back real quick, look at that herbaceous layer down below in both of those pictures versus over here, much more sparse grass, much more of that yellowish color as opposed to a greenish, more lush color. So we get that a little bit of that rain shadow effect as we go to the east side of the coast range. Here you have moderate relief, so you got much more gradual, not as steep. You get lower rainfall, higher summer temperatures, you get extensive grasslands and oak woodlands, and then you get an intermediate wildfire frequency, because some of these places are burning a bunch and some of these places are burning infrequently. You get associations of California grasslands, California buckwheat, blue oak, and blue oak foothill pine. So, basically grasslands, some chaparral species, and then your oak and oak woodland areas. And you get a fire ecology basically very similar to what we talked about last week in the Central Valley, because, this is the area that then is adjacent to the Central Valley and ties right in. And that takes us to our management issues for this area. One of them that you really have to just think about is the idea that these are fire-dependent species. So these areas, it doesn't care that, the environment doesn't care that there's these hugely heavily urbanized areas next to these areas that aren't heavily urbanized. There's fire-dependent species here. These species need that fire, and as long as these species continue to be adapted to fire and adapted to these big, huge crown fires where large areas burn, then you're always going to have this wildland-urban interface issue. So if you're not comfortable with that terminology, sometimes you'll hear the term WUI. And in terms of WUI, it's the idea that you've got basically the urban areas bumping into the wildland areas and then having to deal with the issues of protecting the people in the urban area while also trying to manage the ecology of the wildland area. And so almost to tie all of these things together, you've got the vegetation management issue. So how are we going to manage this vegetation? Because we know it needs to burn. We know what the vegetation type is. Because we've had anthropogenic influence in this area for thousands of years, thousands upon thousands of years. You've got a lot of non-native species in this area. You've got a bunch of native species that are fire dependent and need fire and actually need to burn in these large fires because they're adapted to burning in these large fires. You've got the wildland urban interface because you've got these heavily populated urban areas and they just keep pushing farther and farther into the wildland areas, making it harder to both manage the ecology of the area and manage the human population, not to mention that the majority of fire starts are coming from the humans within this area. And on top of that, we have climate change making it hotter pretty much every year, increasing our minimum temperatures so it never really cools off the way that it does, and just becoming hotter and drier every year. You can look at it and say, well, in the next 40 years, it's only going to go up 3 degrees. 3 degrees is a lot, Think about it. If the area, if you're saying, oh, well, it's only 3 degrees. Well, yeah, maybe, but if you were always at 85 and now it's 88 all the time, or, you know, it was 88 and now it's 91 all the time, you may say, oh, well, what's the difference between 88 and 91? But it's 3 degrees overall, which means you're going to have some days where instead of it being 108, well, now it's 115, you know, in the Central Valley or on the coast. Well, it's on the coast, it's like 75 degrees every day. Well, maybe now it's 80 or 85 degrees every day on the coast, and maybe that's not as, you know, as great as it would be before. I don't know that the coast will feel the effects of climate change as much as, like, say, you know, the folks of the Central Valley will be feeling it, but it's still a huge issue. It's still something that needs to be addressed. If we really want to enjoy the earth the way that we've become accustomed to enjoying it, it's really something that has to be dealt with. And it's a problem that, you know, anytime you mention these management issues of these areas, climate change is something that always has to be addressed because of the massive problems that we are creating upon ourselves in the environment that we supposedly love and want to protect at all times. So it's just something that we really want to think about, especially with the fact that we have these unique areas that just aren't really seen anywhere else in the world, and the fact that, you know, we like these areas, we want to live in these places, and, you know, we want to live in this place that we remember, not this, you know, what it possibly could end up being with the climate changes that we could see with a lot of these species that are adapted to this climate possibly disappearing in the future. That's not something we really want to deal with. So it's something we've got to address. But, you know, as with the other bioregions, we do have quite a bit to deal with in terms of management issues. And that's what I got. So hope you enjoyed it. As always, if you have questions, reach out, and I'll talk to you later.